All right. For those of you who were unlucky enough to be in my Honors Algebra 2 class last year, this should probably seem familiar. So I'm going to buzz through it pretty quickly because regardless of what teacher you had, this information should not be new. We are talking about quadratic functions, which by now you need to immediately go, oh, x squared is the highest power. True. We're looking at two forms, the exact same two forms we looked at last year, standard and vertex. Standard is basically all FOILed out. And in standard form, A is our leading coefficient, and A is significant because it tells us information. We already know that. Over here, A is sitting out in front like it did in the form that we used last time to do like transformations, and nothing about this form is going to be different. What you find inside is still going to affect it horizontally. Everything on the outside is still going to affect it vertically. It's exactly the same in that manner. So regardless of which type you have, standard form or vertex form, a positive A means that that is going to open up and that is going to place the vertex at the bottom, and therefore it will be a minimum. If you have a negative A, it's going to be opening down, which you should already know from what we talked about last time, that a negative A will flip it over the x-axis, therefore it's opening downward, and that the vertex would therefore be a maximum. So let's see. To find that vertex, we know you can go and do second trace max, second trace min on the calculator, but we also need to know how to find it without a calculator. So to notate the vertex, it is a point. So I'm going to be looking at it like this: vertex x coordinate, vertex y coordinate. If you recall, and even if you don't, to do standard form, you'll be taking the opposite of b, which is the coefficient with the plane x in the middle, and dividing it by 2 times a, which is the leading coefficient with the x squared. That's going to be the x term of your vertex. Your y coordinate, you're going to find, like you've found most y's since the beginning of mathematics time, by plugging in your x. So you're going to plug in whatever x value you get to this equation to find out what the y is that would go with it. So if you want to think of it that way, you're saying, okay, I'm going to take opposite of b over 2a to find the first part, and then I'm going to plug in the x part to the original function to find my vertex. The axis of symmetry, if you have a parabola and the vertex is located here at whatever the x term and whatever the y coordinate are, your axis of symmetry has to be a vertical line coming right down through the middle. By this point in your life, you should probably like square with the concept that a vertical line equation only has an x in it. So since it has to be a vertical line, when you go to write your axis of symmetry, you have to write it as a vertical line equation. An equation requires an equal. This is a very favorite thing to do wrong. And that number can't just be any old number. It has to actually be equal to that x coordinate of your vertex, or it wouldn't go through it, and it has to go through it so that it can fold over onto itself. So in both cases, you're going to write x equals that x coordinate, which you found in whatever way is listed above. The y-intercept is exactly that. It's where your parabola is going to cross the y-axis. Whether it's centered around the y-axis or not, it's going to cross the y-axis. And so we want to find out where. So like all points on the y-axis, any point that's on the y, it has an x-coordinate of 0. And that's actually the key to finding it, is that you are just going to plug in a 0 for x, regardless of the form of the equation. You're just going to plug in an x equals 0. Now, if you did that in this standard form, you would notice that you would have a 0 squared here and a plus or minus b times 0 in the middle. So everything cancels out, and your y-intercept for standard form is just going to be that c value at the end, because putting a 0 in here and a 0 in here wipes the rest of the equation out. That is not true in vertex form. You cannot eyeball the y-intercept. X-intercepts are exactly that. Where is it going to cross the x-axis? And you can only have one of these, and here you can have none, 1, or 2 x-intercepts in a quadratic. So Let's pretend I have 2. That's going to be the 2 places that it crosses the y-axis. And so in this case, I need a number here and then a 0 in the second coordinate. And that's how my answer will be written. How do I find them? Well, everybody's favorite way to find them is to factor, and then each factor will produce what we call a 0. A 0 is what we will basically call these from now on. So in calculus, you'll be finding zeros and understanding that a 0 is nothing more than an x-intercept. It's just where it has a y value of 0. And then if it doesn't factor, you get the pleasure of using the quadratic formula once you have a quadratic. So your x's will equal, and then you can sing the little song, I'm sure. The opposite of b plus or minus b squared minus 4ac, the whole shebang over 2a. You do have to be careful with your pluses, minuses, parentheses, and all that business. So that's how you're going to locate all of the things that your parabola has if it's in standard form. That's all review from last time. What if it's in vertex form? Well, the reason vertex form is called vertex form is you can tell where the vertex is by looking at it, and it goes back to the knowledge that you had from last week. Your h in the middle here is going to move it left and right. This is going to move it up and down. Left and right is x, up and down is y. So your vertex is, where does that normally found at the origin vertex end up after you've moved it left, right, up, down? Keeping in mind that the one that's inside goes the opposite direction. So you'll take the opposite of your h value, and then you'll use the k value as is, meaning a positive 2 will indeed move it up 2 if it's at the end, because up 2 will translate into a positive 2y value. We are going to do some number examples too, so if you're lost and confused and having a hard time recalling this from last year, we'll take a second look. But this is just what we did last week. Does it move left, right, up, down? So once you have that, your axis of symmetry still has to go through the middle, so it has to follow that x coordinate of the vertex around, which in this case you found by taking the opposite of h. So in this problem, I'm not doing any math to find the vertex, I'm just looking. So here I had to do a smidgy of math, opposite of b over 2a. Here I have no math. But to be fair, here I really didn't do any math. I could just look at the c value, but here I'm going to have to math because I need to plug in a 0 for the x. So my y value will be whatever the a is, and then 0 plus or minus h squared plus or minus k. And then I'm going to have to math that. The coordinate that is your y-intercept is not going to be a number necessarily that's visible in the equation. Like here, we could just look at the c and that was it. That's not going to happen in this second case, and so you're going to have to plug that 0 in. Technically, you're plugging a 0 in all the time, every equation, linear, quadratic, polynomial, any equation to find the y-intercept. Okay, excuse me. Here to find the zeros, you're trying to find where y is 0. You need it to be, like we said over here, a number and then a 0 for y. So I actually plug 0 in, and then I'm going to know my a value. I'm going to have this that I'm trying to solve for x, and then this. And I'll end up having to solve this using plus or minus square root. Keeping in mind that in a parabola or quadratic graph, you sometimes get 2 x-intercepts. Sometimes if the vertex is on the y-intercept, you're just going to get 1. And then sometimes if it floats around, you're going to get none. So you can get 2, you can get 1, or you can get none, which is what I alluded to over here. But if you forgot what I was talking about, these are the 3 scenarios. So then the last thing that we need to know how to do going into this, and honestly, this chapter is not on quadratics. We did an entire chapter on it, which was super fun back in Algebra 2. We're going to be jumping into pre-calc and doing higher order powers. And so this is just sort of like our jump off point. So we're buzzing through this to lead into 3rd degree, 4th degree, 5th degree, and so on. So you do need to be able to do this last thing, and that is if you were given an equation in vertex form, you have to be able to change it to standard form. It's your lucky day because my pen is pooping out, or your unlucky day because now you have to wait. Basically, there's only going to be 2 steps. If you have vertex form, I guess technically 3. If you have vertex form and you're trying to get standard form, you just need to FOIL it out. And then once you FOIL it out, you need to distribute and combine. So I would say, oopsies, I would say you're going to FOIL that x plus or minus h squared part. Then you're going to distribute the a that might be waiting out in front of it, because you have to PEMDAS, you have to do that exponent before the multiplication. And then lastly, you could potentially have to combine 2 numbers. So how would that look? Well, we're actually going to do some examples. Let me hop right to it. I'm going to include those. Actually, I'm going to put them in a different video so that the videos load. So look for a 2.1 examples sheet video, and that'll walk you through practicing both forms. But have this chart out in front of you so you can kind of determine how much are you relying on the chart. See you soon.